Now that you have understood all the different types of graphs, it is time that we learn how do you write some code to represent this amazing data structure. So let's get straight to it. Hello friends, welcome back to my channel. First of all, what we're going to do is we will try to represent this graph data structure using a adjacency matrix. We will write some code so that you learn how do you initialize a graph, how do you add and remove edges, and then how do you add and remove all of these vertices. After that, we will do a quick pros and cons list to understand where this representation is helpful and where it is not. So without further ado, let's get started. We are going to talk about an adjacency matrix. When you hear the term adjacency matrix, what comes to your mind? The first thing that should come to your mind is a two-dimensional matrix. So let us say I have this graph in front of me and you have to represent this graph using some sort of a two-dimensional array. How do you get started? For beginning, let us say this graph has total of 4 nodes, correct? So what I can do is I can create a 2D matrix that has 4 rows and 4 columns. So in this matrix, what we can do is we can represent each of these rows using each of the row and column. So this matrix can kind of tell me, okay, what is the connection between node 2 and node 3? And that connection will be represented by this particular value, right? To get started, there is a connection between node 1 and node 2. There is an edge, right? So you're looking at node 1 and you're finding the connection between node 2. To represent this connection, what I can say is I can write down a value 1 over here. This 1 is telling me that there is a connection between node 1 and node 2. And since this is an undirected graph, that means if there is a connection between node 1 and node 2, there is also a connection between node 2 and node 1. The connection is both ways. So there is a connection between node 2 and node 1 also. That means you have to fill out this particular value also. Similarly, moving on to our next edge. My next edge is connecting nodes 2 and 3. That means node 2 connecting with node 3. You have to fill up this particular cell. There is a connection, so I will write down 1 over here. The reverse is also true. Node 3 is connected to node 2. So node 3 is connected to node 2. So I will write down a value over here. So this matrix is kind of representing this graph. I can accurately determine if there is a connection between two nodes or not. Similarly, I have these two edges as well. Both of these nodes are connected. 1 is connected to 4 and 3 is connected to 4. So I will fill in these two values also. What about all of the other remaining values in this matrix? You will simply write down a 0 over here. What we just did is we represented our entire graph using a matrix. If someone asks you immediately, okay, is there a direct connection between node 1 and node 3? How can you find it out? You can simply look in your first row and the third column. Look at this value. This is a 0. That means there is no direct connection. If someone asks you, hey, is there a connection between node 1 and node 4? So you will look at the first row and the fourth column. You see a value 1 and that means there is a connection. Now, what happens if you want to add a new connection? Let us say I am adding a connection between node 1 and node 3. I added a new edge, but you have to make the corresponding changes in your adjacency matrix also. So node 1 is now connected to node 3. So you need to update this value. Also, there is a connection from node 3 to node 1 also. So node 3 is now connected to node 1. This is how your matrix updates, and your matrix is giving you a picture of the current state of the graph. Notice that it is an undirected graph. That means if there is a connection from 1 to 4, then there is also a connection from 4 to 1. What would happen if this graph had a directed edge? So now you can see that there is a connection between 1 to 4. So we will look at row 1 and column 4. So we can update this value. But the important thing over here is there is no connection between node 4 and node 1. So row 4 and node 1, there is no connection. So this value will remain a 0. That is how you will handle directed and undirected graphs using a adjacency matrix. Another thing to notice over here is that currently this is a unweighted graph. All of these edges, they do not have any weight associated with it. All of the paths are equal. There can be a scenario where the edges have some weight associated with it. So let us say I am writing down 3 over here. That means this edge has a weight of 3. Your adjacency matrix can handle it. Just look at node 2 and node 3. So node 2 and node 3. Currently, you have written a 1 over here. But since this is a weighted edge, what you can do is you can write down a 3 over here. And similarly, for node 3 and node 2, you also need to update this value. What did we just do? We took care of the fact that this adjacency matrix can handle a weighted graph as well. If someone makes any query, is there a connection between two nodes? If the value is 0, then there is no connection. For right now, node number 2 and node number 4, they do not have any direct connection between them. If the value is anything other than a 0, then you can determine that, hey, there is a connection and this is a particular weight of that edge, right? The last part is, how do you handle a new vertex being added to the graph? So let us say I am adding a new vertex over here, correct? Now I have 5 vertices. What you need to do is, you need to resize your matrix. You will have to adjust for an additional row and an additional column. Currently, this new node does not have any connections, so I will write down a 0 over here. Let us say that this new node makes a connection with node number 3. So this new edge gets added and you will have to make the corresponding update in your adjacency matrix as well. So node 5 is now connected with node 3, so we have to update this value. And node 3 is also connected to node 5, so update one more value. That is how you handle all of the basic operations in an adjacency matrix. So this is the crux about how you represent a graph using an adjacency matrix. You took care of all of the basic operations and all the different types of graphs as well. So based upon all of this idea, let us now try to write some code and see how we can do all of these things programmatically. This is a basic code about how you can go about initializing a graph. I am creating an adjacency matrix and I am initializing the number of vertices. And whenever you have a constructor, you can just pass in the number of vertices that you want in a graph. Based upon the number of vertices, let us say my target graph looks like this. This is the graph that we just worked with, correct? So this graph, it currently has 4 vertices, right? And that is where we want to go. Forget about all of the connections right now. When you initialize your constructor, you just pass in the number of vertices. And then you assign the number of vertices to your variable. And based upon the number of vertices, just create a square matrix of the same number of rows and same number of columns. So this will now initialize a 2-dimensional matrix and all of the values will be 0. Let us say I call my statement like this: graph G equals to new graph 4. So this is the number of nodes and they are passed into the constructor. It will create my adjacency matrix with 4 rows and 4 columns. And once it is created, all of the values are currently initialized to 0. Notice that we have not formed any connections up till now. This is where we want to go, correct? So definitely the next part is adding and removing edges from a graph. We established our initial adjacency matrix now. How do you add an edge? Just look at this function. I take in 2 parameters that are representing the source and the destination. So let us say I am trying to create an edge between node 1 and node 2. So I will call a method add edge 1, 2. That means I am sending 1, 2 in over here. And how do you create an edge? First of all, you will change the value of row 1 and column 2. So this value becomes 1. And then you also change the value of row 2 and column 1 because it is an undirected graph, correct? So row 2 and column 1, this value also changes to 1. So that is how you will add an edge between 2 nodes in your graph. Look at your target graph. This is where you have to reach. So currently you just added 1 edge, 1, 2. You have to add 3 more edges. So what I will do is I will kind of call these 4 different functions. So these are adding all of the required edges. Notice that you can change the order over here. You can either do add edge 4, 3 or you can also do add edge 3, 4. This is gonna update your adjacency matrix to represent the state of your graph. So far so good, we have now added all the edges. Let us say you added an edge by mistake and you created a connection between node 1 and node 3 also, right? So now you need to define a function where you can remove an edge as well. So just like the add edge function, you will create a new method remove edge. And once again, it takes in two parameters, that is the row and column. And what do? Just simply go through the row and column of both of the matrix and then put the value 0 in here. So if you had added an edge 1, 3, then you can remove the edge 3, 1 or 1, 3. And then it will change the value 3, 1 and 1, 3 and it will change them to 0. So that is how you add and remove edge in your graph. So where did we reach? Our matrix is now representing our target graph. Let us now try to take a look how do you add and remove vertices from this graph. Just look at the target graph now. I added a new vertex over here and it has a connection with node number 3. Right now, my adjacency matrix is representing this graph without the new vertex, of course. And if you try to recollect, how did we add a new vertex to our adjacency matrix? We had to create a new row and a new column that was representing the new vertex, right? So, a two-dimensional array or a matrix, you cannot just add a new row and a new column to that matrix, right? What you will have to do is, you will have to initialize an entirely new array of the new size. So, if you notice the function add vertex, when I call this, it initializes a new adjacency matrix with the increased size. So, this will simply create a new matrix which has a capacity of 5 cross 5, and then it will manually copy all of the elements using this for loop. So all of these values, they will get copied over to my new matrix. But at the same time, I also have a new row and a new column which can be used for my new vertex. And once this function ends, what do? You assign your original adjacency matrix to the new matrix. So now my graph will be represented by this new matrix and I increase the count of number of vertices. Now all that is remaining is adding the edge. So you call a function add edge 3, 5 and it is gonna update the respective values in your new adjacency matrix. The next question that comes to your mind is, okay, how do you delete a vertex now? To delete a vertex, you first of all need to know, okay, which vertex do I have to delete? So just look at this method now, remove vertex. It takes in a parameter that defines which of the vertices that you want to remove. Let us say you want to remove vertex number 2, right? So that means this entire second column and the second row, it will disappear. And once again, you cannot just remove rows and columns from a two-dimensional matrix. So once again, we will have to follow the same approach. You will create a new adjacency matrix with the reduced size, and then you will copy all of the values except that particular row and that particular column. All the other values will just get copied over and you will once again get a new adjacency matrix that you are going to swap out. So this is how you perform the add vertex and the remove vertex in a adjacency matrix. Just notice how costly it is, because every time you're adding a vertex, you will once again create a new matrix and copy all the values. To remove a vertex, once again create a new matrix and copy all the values. The time complexity of both of these methods is order of n square, and it is quite costly. So we have to use it by caution. So this kind of summarizes how you perform all of the different operations on a graph using a adjacency matrix. Now let us just do a quick pros and cons about using this type of representation. What are the good things that you understand about the adjacency matrix? It is a really simple structure and very easy to understand. Just by looking at the matrix, you can determine that, hey, there is a connection between these two nodes, right? And try to think, when your graph is very dense, example, Each node is connected to a lot of different nodes. Then this matrix will have a lot of ones, correct? And this becomes very efficient. You are able to make all of these connections very easily, and you can make so many quick queries as well. If I ask you, hey, is there a connection between these two nodes? You can simply go to this value and tell me yes or no. So this is the order of one operation. And that kind of sums up why you would actually try to use a adjacency matrix. At the same time, an adjacency matrix has some disadvantages as well. So, first of all, the space complexity. If you notice, if I have a graph of 10 nodes, then I need a space of 10 cross 10. That is straight away order of n square. And that is not desired in a lot of places. Try to think about it. All of the operations are very expensive. If I ask you that, okay, add a new node, then you will have to create a new matrix once again and then copy all the values. And similarly, to delete a vertex as well. So it is not efficient when your graph is very dynamic. When you're adding node, removing node, making all of these changes. So be cautious when you are handling a graph in those type of scenarios. Also, it is very memory expensive because you just need a n squared space just to store your graph, and then all the operations are separate. So whenever you are choosing how to represent a graph, just keep in mind all of these pros and cons and make your choice wisely. I hope you got some good understanding about how you can represent a graph data structure using the adjacency matrix. As for my final thoughts, I just want to say that take out some time and try to work out some examples on your own. Just try to create some random graphs and try to make that adjacency matrix. Try to add those edges and see what all operations did we talk about. Why is it not always beneficial to have the graph represented as an adjacency matrix? Why there are so many costs involved? You will understand a lot and it will clear up your mind as well. While going through the video, did you face any problems? Or do you have any other thoughts about representing a graph using a adjacency matrix? Tell me everything in the comment section below and I would love to discuss all of it with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I keep on simplifying programming concepts for you. Also, a huge shout out to all the members who support my channel. You guys really keep me going. And it also gives you pride to reply to all of your queries. I will be soon coming up with my next video on adjacency lists. So until then, stay tuned and see ya.